Hello everybody, it's Andrew Hutchings here, still not a licensed physician, never giving medical advice, purely educational. And this video is where we are at publicly with anti-aging technology. Now this video is not going to cover every possible route you can do to extend your life, but this is going to be the real best thing that we've got publicly at the moment. So, for you to understand it, I have to give you some background. Cells, after the egg cell and sperm cell come together, they start changing. So they start dividing, and those cells start changing. Their DNA starts changing. DNA is not just this helix, just free-floating. It's all twisted up, and it's got other molecules bound on it that keep it locked in certain ways, and parts of it more twisted than other parts, and parts that are more twisted than other parts can't get read to make RNA, to make proteins, so they're essentially like they don't exist, kind of, but if they open up, then they exist again, and they can do their thing, and yeah, so that's the gist of it. As the cells are dividing and the organism is growing, different parts of it get closed off, molecules go on there, help it close down, and only the parts it needs for its specific role stay open, and that is mediated by other molecules. Other molecules from the mother's body and then from the organism itself tell the cells in the new organism how they should twist up, which molecule should go where in the DNA to twist it up, and stuff like that. So by the time you are looking like a human, I mean you're always a human, but by the time you're a baby, let's just say by the time you're a baby, I mean it's going to be a little bit different for baby versus adult, but let's just go with adult for the sake of it. Now, your cells are pretty much all in a state where they can't simply divide and make whatever they want, because the DNA has twisted up. And those cells, if they were to divide, would make other ones that are similarly twisted up. But they're also not really dividing a whole lot. Some cells can divide more than others, but also these cells, I'm not an expert on why they can't divide forever, and it's not currently known 100% why they can't divide forever. But one reason is that the telomeres on the ends of the DNA, so just think of that helix before it's all twisted up, there's extra parts on the end, and as those wear down, once they wear down too much, then the DNA itself can start wearing down, and that would be bad, because then you'd get erroneous creation of things, and that would be very bad. So once the telomeres get short enough, the cells terminate those cells that have that DNA. So that's one reason why cells can't just divide forever, even if they're highly dividing cells. Okay, so when you're an adult, all the cells in your body are different. They're differentiated. They have specific roles. You have skin cells, you got eyeball cells, you got tongue cells, you got muscle cells, similar to tongue cells. So they're all different. They have different patterns of which parts are twisted up more than other parts, and they are aging. Telomeres are getting shorter. Cells are dying off. Okay, so how is it that every time we have a child, that child does not start, say you have a child at 20 years old, and someone else has a child at 25 years old. Why is it that, and let's ignore the possibility that the birthing parents got serious DNA damage from being in Chernobyl to their sex cells, but normal people in an ideal environment where they're not getting damage from their environment. Regardless of what age you have your children at, in an ideal environment where you're not getting blasted by radiation, your children are going to always be born at what we'll call age 0. They're not born old. So how is it we go through life, we get older, but we are able to combine our cells together and make new stuff that starts at age 0. Even if you're 90 years old and you impregnate a girl, or if you're a woman and you manage to somehow have eggs at 90 years old, but probably you're not going to, and you somehow get pregnant and you somehow can manage that. See, the issues with this woman probably aren't going to have kids at 90 years old. So I'll say it as a man. You impregnate a woman when you're 90 years old. Your kid does not start off any older unless you're exposed to damage to your sex cells, whether it's chemical or radiation, like in an ideal environment. Your kids are going to be the same age as if you had them earlier. Why is that? It's because when your cell goes inside the egg cell releases certain chemicals that you could say reprogram the DNA inside your cell. Remember how when you are first starting off, I said that the chemicals from the mother's body influence the DNA and tell it like what molecules to put on it to twist it up in certain ways? Well, your cell, when it goes into the egg cell has certain chemicals that do something similar, but it tells it all to like take off those extra molecules that twist it up and put different molecules on there, and it like unwinds it all, in a sense. And now you are back at square one. Infinite potential, basically. Seems like it. Who knows for sure? Yes, that is how, when we have children, they start off at age 0, as I'm calling it. Because the egg cell releases chemicals, tells the DNA, like, triggers processes to change the molecules that are bound to the DNA, and then it unravels, and now it can do anything, because it's not being locked up. Remember, when it's, like, twisted together, it can't be used. So only part for, like, say, your skin is untwisted and available to do its stuff, or only part for your muscle. But now it's all unraveled inside the egg cell, and it can do anything. It can divide. Now you got 2 cells that can do anything. They divide. Now you got 4 cells that can do anything. They divide. Now you got 16 that can do anything. Then after you get a whole bunch, then they can start closing off certain parts, and now this one's skin, this one's muscle. So why is this relevant to our current anti-aging? Like, we're not going to just turn into babies and go back to age 0. Relevant in 2 ways. Number 1, the more conventional way is you take cells from your body, take them out, put them in culture, expose them to these chemicals, grow more cells, and now you inject them back into you. Stem cells. You have fresh cells that can do stuff. Say you got heart damage. You could try to activate the stem cells that are already around your heart to be used, but say you don't have enough for some reason. You can inject stem cells, have them be used. But what if we want to take it a step further? The step I'm interested in, personally. I didn't come up with it. I mean, I did come up with it, but someone else also came up with it. Like when I decided to see if it had been done. It had been done a few years ago publicly. I actually think it's probably been done a long time ago, because I think if I thought of it just on a whim, probably someone else thought of it a long time ago who was really focused on it. But who knows, maybe I'm not giving myself enough credit, but when I looked it up, it had been done 3 years ago. So what this extra step is when instead of reprogramming the cells outside of your body, you reprogram them inside of your body. Now here's an issue, but it's kind of like a self-solving issue. Issue 1 is that you can't just reprogram all of your cells in your body to stop being what they are and be infinite potential stem cells, because you'd be like I don't know exactly what you'd look like, but you'd be like a blob of cells. You wouldn't be alive anymore. Who knows? We haven't done it, so who knows? Maybe it would be alive, and maybe it can turn back into a human. I don't know. But I wouldn't want to take that chance. It certainly wouldn't, probably wouldn't be good to just turn up all your cells into stem cells, because you, like I said, you'd be like a blob. Issue number 2, which kind of fixes issue number 1, is that when you expose the cells to these chemicals, and when you divide them, it doesn't work for all of them. I don't know what the paper I read said, but it's like a pretty low percentage of cells that it works with, because clearly we have not mastered it yet, publicly at least. So the fact that it doesn't work most of the time kind of fixes the issue of if it happens to all of your cells. Good thing, kind of. So now how can we expose all of the cells in the human body, or a lot of them, to these chemicals that are normally excreted by the egg cell? 15-year-old me would have gone, how do we get these chemicals in the human body? Like, how are we going to ingest them or inject them or get them transdermal, or how are we going to do it? But older me goes, oh, that's simple. Especially considering that these chemicals are from egg cells to begin with. They're amino acid-based chemicals, chemicals of the human body, because that's what the human body makes, is amino acids. So what we do is we have the gene sequence for the amino acids, and we have the gene sequence for the other there's one chemical, we have the gene sequence for the amino acids that make that molecule, we have the other gene sequence for the other amino acid sequence of the other molecule, and we have all those sequences. We connect them together, or we put them in separately, depends on how you want to do it. But let's just say we connect them together first, and then we take, this is one way, there's multiple ways you can do it, but let's just say we do like a common laboratory technique of you get circular DNA from bacteria called a plasmid, and we cut that open, so now it's and we insert our pieces, and we put the enzyme to like reconnect it, and now you've got a circular DNA that has those gene sequences for the amino acids to make those molecules that are normally from the egg cells. Now, you could leave it at that. Or you can also add in another gene sequence that only turns it on when exposed to another molecule. It would be useful. Doing a lot of talking while sick. Mostly better. Technically still a little sick. So yes, as I mentioned in recent videos, you can have gene sequences that are only turned on when exposed to another molecule to get the right stuff to all bind there, and then turn it on, start printing it out. And so you can add that in. Good idea. Because when things go uncontrolled, often not the best. Good idea to have a control mechanism that you can control consciously. Because your body's going to try to do stuff with it, but I mean something that you could choose consciously to do exactly how you want. So let's say we make it activated by tamoxifen. It's a common chemical used for it. You don't want to do it if you're a bodybuilder, because then you're going to accidentally have it done whenever you take your tamoxifen, but let's just say tamoxifen. So now those molecules that are normally released by the egg cells are only going to turn on and be released when tamoxifen is taken. So we take that plasmid and we get it into the human body. And then whenever tamoxifen is ingested, it turns on the reading of those genes, makes the RNA, makes the amino acids, and your cells get exposed to that mixture of molecules, just like in the egg cell. And they go back to being stem cells, and then because they're next to all of your other cells, they get other molecules excreted by your other cells, and they turn back into whatever cells they're around. But in that process, their telomeres also, I forgot to mention this part, their telomeres even got re-lengthened. Everything got undone. All of the things that closed off or make it older, they got taken off when it was in the egg cell environment from the molecules. But now to cover how we get it into the human body. And my throat is bothering me, but I will say one way. One way is you put it in a virus. So yes, for this example, we used circular DNA. You could also just have it in like a retrovirus and incorporate it into your actual genome. It just comes down to your preference. But yes, we could put this circular DNA into a virus that doesn't really have any pathogenic activity. And then you infect yourself with the virus, it spreads all throughout your body, it gets that circular DNA into a lot of your cells, And now anytime you take tamoxifen, it activates it, and you get the environment like an egg cell, and your cells go back to stem cells, they get their age slate wiped clean, and then they turn back into your normal bodily cells for wherever they are. And that is what I consider the most interesting thing we currently have for anti-aging. Hope you like this video. My website is andrewhutchings.org, where you can hire me for consultations, and my Instagram is natural_true_fitness. Here, where you get the really good information, not just